Welcome to the channel. We're going to cover a little battery project that I'm working on. Going to make this fairly short and just show you some of the highlights. Basically, we're going to take these 12 balance board batteries that are 10S2P. We're going to put them in our frame here. Power goes through the bottom. On the bottom side here, we've got our electronics. We're going to be using a couple bus bars to bridge everything together, make them parallel. And this system here will be the power monitoring, where it'll let us know how much amperage, how much wattage, how much battery percentage is left. This has a wireless component, a little display that we'll put on the outside of the case. We'll be wrapping this all up in a Pelican case with some wheels so we can tote it around, and a 200-watt inverter on top. So I will come back once all this wiring is done and show you the next steps. Alright, we finished up the wiring. If you notice here, we've got 12 of the batteries in parallel now using these bus bars. We've also added our cables to the load, which will be a 2000 watt inverter. We've also added this little guy here to supply power to the power monitoring system, gives us our voltage and amperage. We've also added on these cords here that'll give us a terminal output, so we can charge it and use externally if we want to power something other than the inverter. So next steps, we're going to be changing up that Pelican case there and adding the inverter on top and doing a little bit of modifications on the inside. So stay tuned for that. Alright, we're getting really close now. If you noticed here, we've got our charge port wired up. Decided to hard code it into the bus. I was going to do a temporary connection. I was like, that's just not wise. So we have also, the last things to do is install the batteries. The inverter is strapped in and wired up. And then after we get the batteries set up, we'll do a capacity test. And then also try to do a max test to see if we can get the full 2000 watts out of the inverter. So stay tuned for that and we'll finish this up. Just wanted to show the battery install real quick. 3D printed these brackets. I've super glued the pillars together to give it a little more stability. So I had to take this front section off to get to the screws using some M4 hex caps. And like I said, when we're done, we'll have 12 in parallel. Welcome back. We have finished up our wiring. We have mounted the batteries. We now have the inverter mounted and wired up. I have spent the last 16-20 hours discharging this down to a zero state. One of the great things about this inverter is that it has a working voltage of 31 volts up to probably 43 or 44, but I'm just going to take up the batteries to 41. So the great thing is the BMSs should never really kick in unless there's a true issue. So when this power is down to about 31 volts, it'll start chirping. So that's what I'm going to set my voltmeter to as 0%. Right now it says 31.45. This inverter pretty much I think reads somewhat close, but not exact. And so when that hits 31 on the discharge, it will just power down, or start chirping at you. Eventually it will power down, but I'm just going to consider the first time it chirps, it starts to cut voltage on the inverter as 0. So now we're going to take the long journey of charging it up at 10 amps, and we'll use the meter here to see how many amp hours we get, and then we'll set that as our 100%. All right, we finally got this sucker charged. We got 47 amp hours. And that is from 31 volts up to roughly 41. I'm going to give the batteries the ability to have that buffer so they'll last as long as they can. So far everything has worked very well. I'm about to do a load test, take it indoors and run a bunch of computer stuff and see how well it does. We'll catch you inside. Alright, we're inside now and I'm currently powering my home office. I have 5 monitors on, a laptop, 400, 300 watt power supply on a big gaming type PC. 3D printer is heating up and a fan is turned on. And we're barely using 10 amps or so. It was peaking at 15 in it sometimes. So to give you an idea of the capacity, This should probably power this setup, now it's up to 14, 15, for about 4 or 5 hours. So this is a really handy supply. This should help quite a bit to run even my entertainment center or a computer or a fan during a lights out where the power's gone out. And that's what I usually use these for, and great for taking on picnics and other things where you just need to have some power, camping. So last test will be see if we can power saw and see if it can handle the peak of the motor spinning up, and we'll do that next. Alright, we're out here in the shed. This is the most powerful thing I can think of that I have to see what we can put a load on, and we've got a 15 amp looks like table saw, and you know table saws and other motor devices draw a lot of energy at first, so let's see if our battery pack and inverter can handle it. We got it powered on. Let's see what happens. I would have to say that worked very well. Just want to finish up the video and say thanks for watching. If you have any questions, feel free to leave them in the comment section, and I'll be glad to answer them if I can. And we'll hopefully bring another project to you at a later time. Have a good one. Bye.